Quantum Computing and Cryptography, Max Stevely, Conor McCleary and Benjamin Bullis. Quantum physics addresses the behavior of atoms and basic particles such as electrons and photons. As a result, a quantum computer works by manipulating the behavior of these particles, but in a very different way than traditional computers.
So I'd like to talk about this article I read the other day about quantum computing and the consequences it will have on cryptography and its future developments. The first point I found interesting was how it talks mostly on the negative impacts of quantum computing, such as its vulnerability and how it could be at risk if the power of quantum computers got into the wrong hands. Although I agree that is true, I would like to expand and emphasise what quantum computers can do for society in a positive way. As society develops, we are already reaping the benefits of quantum computing, for example, the medical benefits. There was a recent clinical research trial in which a woman who had been diagnosed with breast cancer was used to see if the extreme position of the quantum computer would be able to locate and destroy the cancer cells, therefore curing them. Also, I'd like to talk about how quantum computers could create private keys, which would then be able to resolve the vulnerability of systems due to hackers being able to break the keys. We use around 17 billion devices across the globe, so the security of private keys could provide us that they could provide us would be astounding.
Although private keys are good, cryptography is also at risk due to quantum computing, as the rate to decrypt ciphers for private data is so quick that they aren't worth using anymore. This is because the algorithms made to decrypt ciphers using quantum computers being highly optimized, taking less than half the time of usual decryption methods.
Traditional computers versus quantum computers. It's clear that a quantum computer isn't simply just a more powerful version of today's commercial computer. Just as similar and as much as a light bulb isn't a more powerful candle. It is a technology that has overtaken the tradition and norm of the past. To reinforce this ideology, through the creation and betterment of candles, it will simply not result in the creation of a light bulb. On the other hand, a light bulb is a separate technology that is founded on a deeper scientific understanding. A quantum computer is a new type of device based on the science of quantum physics. And just as a light bulb alters society, quantum computers have the potential to impact many parts of our life, including our security needs, healthcare, and most importantly, the internet. A conventional computer simulates the heads or tails of a coin as a bit, a 0 or a 1, or a current that flips on and off inside your computer chip. A quantum computer, on the other hand, is quite different. The identity of a quantum bit is more ambiguous and non-binary. It can exist in a superposition or a combination of 0 and 1, having a chance of being either 0 or 1. In other words, its identity exists on a spectrum.
I've heard quantum entanglement is a large part of the way these computers run. It's in simple terms, completely opposite version of a particle is made, therefore meaning having one particle's data, you immediately know the other particle's data. This therefore means you can transmit data from one point to another almost instantaneously. Have you heard of the idea of Schrödinger's cat?
Yeah, I have, but would you like to expand on that?
So basically, it's a thought experiment by Erwin Schrödinger, and it involves a cat, a radioactive isotope, and poison. And in a box. And in the box, the radioactive decay causes the poison to go off, killing the cat. But because radioactive decay is a random occurrence, it means at any time the cat is either dead or alive, meaning that when you're outside the box looking in, it is in a superposition of being dead or alive. And this basically explains how particles are in two positions at the same, two like different states at the same time. And that is the idea of quantum superposition.
This concludes an elaboration and expansion on the topics and on the article provided.
Thank you for listening.
We hope you enjoyed.